A very good morning to Dr. Shaizan. Today our group would like to do a brief presentation on the HPDP project that we have done recently. So for the case study 1, we are going to prepare the design and implementation of a relational database on a university academic system. So the university is currently using a MySQL, which is a client-server architecture, as a RDBMS. So I would like to explain some of the client-server architecture downside. The server can get easily overloaded when it receives too many simultaneous requests from the client, and if the server fails, then the whole system network will become a failure. And for the MySQL downside, it doesn't scale when the size of the database becomes larger and larger, and then it is prone to data corruption, and MySQL does not support any SQL check constraint. So the solution suggested is to change from MySQL to AWS. So this is our suggested AWS architecture. So for the AWS Aurora, we actually put two AWS Aurora in each availability zone. The second one will be used as a purpose of backup to prevent the primary Aurora down. So for the AWS Elastic Cache, it is used to accelerate the performance of our database and system performance. And for file system, we have chosen AWS S3 and AWS EFS. AWS can control the access to data, replicate data to any region, as well as data security. For AWS EFS, it provides an elastic and encrypted file storage, and it can use for data transfer and data security.
Thank you, Alvin. For every system, we need a processing unit that can help us to process and store data. Therefore, in our architecture, we use AWS EC2 to help us accept, process, store, and output data. But for the better management of these EC2 instances that we will use, we cluster several EC2 instances into two containers using the AWS Elastic Container Service. The reason we do this is that we'll have one cluster as web server that is responsible to serve static page, while another one will be as the app server that serves the dynamic site content that is written in languages like PHP, JSP, etc. While for both containers, we have an auto-scaling group to help us to monitor and maintain steady system performance, but automatically adjusting the system capacity. Next up, I would like to talk about the underlying hardware decision we have for our architecture. In our architecture, we need NAT gateway and also application load balancer. For NAT gateway, we place one NAT gateway for each availability zone, and both NAT gateway are in the public subnet. The reason we do this is that the NAT gateway can help AWS resources like AWS EC2 and AWS Aurora database to access internet for services like software updates. And the best thing for NAT gateway is that for security purposes, the internet cannot establish connection to these AWS resources. While for application load balancer, it can make sure that no single server will be overloaded with requests. This can lead to better system performance and also prevents internet attack like DDoS attack. Lastly, for other details of the architecture, you may pause the video here to understand the detail further.
Next, I would like to talk about case study 2, where our group chose the first scenario. In this scenario, Simple Mart Wholesale Corporation is a retail company based in Southeast Asia that mostly sells daily necessities like meats, drinks, detergents, and so on. They are quite similar to Tesco and Costco. It has expanded to other continents over the years to regions such as China, Australia, America, with 5,000 stores worldwide, but still they use a centralized database that is based in Southeast Asia, which has raised many problems such as issues having accessing the database and system performance. Therefore, we like to suggest for them to use a distributed database system. Why? It has increased reliability and data availability, where database is distributed all over multiple sites, improves system performance using subqueries, easier to expand in the future, where upscaling is made easier, more economical than centralized database in terms of upscaling and communication cost, and it has modular development outlook for scalability and expandability. In our architecture, for the database allocation, we suggest using data replication, where copies of one or more database fragments are stored at several sites, which allows for data reliability, increased data access speed, enhances server performance, and can accomplish disaster recovery, where our data replication will be using full data replication, allowing for whole database to be replicated at every site, enabling the database to be available almost everywhere in the combinational network, ensures and maximizes data availability and redundancy across the entire wide area network, whilst implementing asynchronous data replication, where the database will be instantly changed and modified if there is any changes or modification. And then finally, we will use a database fragmentation, which implements horizontal fragmentation and vertical fragmentation, which is suitable for this type of retail company.
For the data security, one of the measures we take is authentication and authorization. We restrict the database login through the username or password combination. We use business VPN for the access control, and only the employees with a credential can access the data. Besides that, we also implement data encryption, validation of input data, and also data auditing. For the database backup and recovery strategy, one of our strategy is using full database backup and point-in-time recovery (PITR). Other than that, we also use the recovery strategy provided by the distributed database management system, which are the power failure recovery, disk failure recovery, consistent checkpointing, fuzzy checkpointing, and also undo and redo operation. For the distributed query processing, we choose our strategy based on the data transfer cost. To calculate the cost, we multiply the cost per byte of the data transferred with the size units in byte. There are three strategies we can take, which are shown here after the formula. We calculate the data transfer cost for each of the strategy, and we choose the strategy that have the lowest data transfer cost. For the infrastructure changes from the centralized database system to distributed database system, the system had become easy to expand, the data stored is more secure, and the systems is become more complex. Finally, thank you so much for watching our video.